Let's solve LeetCode 128 longest consecutive sequence. So given an unsorted array of integers nums, we want to return the length of the longest consecutive element sequence. We must write an algorithm that runs in O of n time. So what that means is, let's say nums with 100, 4, 200, 1, 3 and 2 is given. The output here is 4. How? The longest consecutive element sequence is 1, 2, 3, 4 because 1 is present here, 3 is present, 2 is present and 4 is also present. So the longest consecutive sequence is 4. Over here we have 0, 3, 7, 2, 5, 8, 4, 6, 0, 1. The output here is 9. Why? Because we have 0, then we have 1, then we have 2, 3, 4, 5, 6, 7, 8. Look, I conveniently missed out on 0. There were 2 zeros here, I only counted one of them. So that's one thing to remember. We want to return the length of the longest consecutive element sequence. Even if there's a duplicate, we don't count that as a consecutive element. That's an important consideration. And yeah, that's basically the question. Let me just copy this. I'll paste it over here and then we can start understanding how we can solve this problem. So the very first approach that comes to my mind is sorting this entire array. If I just sort this entire array, I'll just get 1, 2, 3, 4, 100, 200. And we're done. We can just go over and see how many consecutive elements are there. To check the consecutive elements, I can just check, hey, after 1 do we have 2, after 2 do we have 3, after 3 do we have 4, after 4 do we have 5. Oh, we don't have 5. So in that case, till here we have our max sequence of 4. After 100 do we have 101, and no, that's not the case either. After 200 do we have 201, and that's not the case either. So our answer becomes 4, and that would be our answer. But the problem with this is the time complexity is O of n log n. Since this is O of n log n, we can't use this. We have to write it in O of n. That's the question. And also it makes sense to have it in O of n, right? Because all we need to do is traverse this array once. Anything other than that is kind of like doing the thing redundantly. So how are we going to solve this now? So the next approach that comes to my mind is, well, first asking the question, why did we have to sort? What was the intuition behind sorting the array? The reason we sorted the array was so that we could have all of the nearest elements together. So 1, 2, 3, 4 would line up together. Is there any other way I can line up the elements? And to line up the elements, we don't really have to visually get them together. The reason we had to do 1, 2, 3, 4 here is pleasing for our eyes. But machine does not have to do it the same way we figure out if there's a sequence or not, correct? Machine can do its task. Because what we can do now is, let's say I go over 4. Now what I'll do is just check, hey, is 3 present in this entire list? Yes, it is present. Is 2 present in this entire list? Yes, it is. Is 1 present in this entire list? Yes, it is. And that would be our answer. The same could be happening for 99 or let's say 100. So 100 minus 1 is 99. Is 99 present in the list? Nope. So the max length till here is 0 or 1, whatever you want to call it. Here we have an edge case which says, or actually we don't have the edge case, but let's say there is only one, there is no consecutive sequence with us. So in that case, the answer would either be 0 or 1. I think the answer would be 1 because we just return 100. 100 is the only consecutive sequence. But either ways, let's go to 200. In 200, what do we have? 199. Does 199 exist in this list? Nope. So, well, we don't count that either. Then for 1, we'll do 0. Does 0 exist? Nope. Does 2 exist? Yes. Does 1 exist? Yes. Does 0 exist? Nope. So still the maximum we've found is 4 because we had a comparison to be made between 4 and 2 and 4 was the bigger one. So till now there's 4. Now let's go over 2. So 2 has 1, 1, after 1 we have 0 and 0 is not present. So the answer here is just 2 and 1 as the consecutive sequence. And that is not the correct answer either. So we'll just return 4 from here, correct? But there are various problems with this approach. The first problem we'll encounter here is what we're trying to do is find an element. What we're trying to do is, if this is n, we're trying to find n minus 1. And if n minus 1 exists, n minus 2. If n minus 2 exists, n minus 3. And we're trying to find that in a list. But the problem is, if we search in a list, the time complexity anyways becomes O of n. And since we are looping through the array within which we are calling O of n, it's going to be O of n square, which is worse than O of n log n. What can we do to solve this? Well, my first approach is going to be to convert this list into a set. So I'll create another set which contains 100, 4, 2, 100, 1, 3, 2. The reason I'm able to convert it to a set is because anyways we don't care about duplicates. If we convert a list to a set, the duplicates will be lost. I anyways don't care about the duplicates. I anyways had to ignore them. So it's fine if I convert it into a set. Okay, but in some questions maybe you have to include it. So just make sure that's not the case. In our case, we can convert it to a set without having any problems. Cool. Now that I've found out the set, what I can do is find out n minus 1. So 3 is present in the set or not, and that will take me an O of 1 operation. But I'll have to do this for every single one of them. So for 99, and if 99 is not present, I'll just leave it over there. 3, 2, 1. Then for 200, 199. 199 is not present, so we just cancel it. Then for 1, there's 0. It's not present, cancel it. Then for 3, we'll have to do 2 and 1. For 2, we'll have to do 1, and then 0 is not present, and we are done. But this is a good case scenario, actually. What will happen if the numbers are closer? Let's say we have 99, 100, 101, 102, 103, and let's say also 98, 97. What will happen in this case? So what we'll try to do here is, first we are on 99, we'll try to find out 98 in the set, we'll try to find out 97 in the list. And then 96 is not present, so we cut out. So till here we have 2. Then for 100, we'll have to do 99, 98, 97, 96. Then for 101, I'll have to do 100, and then the same 99, 98, 97, 96. For 102, again 101, 100, 99, 98, 97, 96. 103 will also be 102, 101, 100, 99, 98, 97, 96. You see where I'm going with this? The problem will become, again, this will be O of n square. Because in the worst case scenario, we're duplicating the amount of work we're doing again and again. There's a lot of duplication going on, and we don't want to support that. In average case, in your good case scenario, it would be O of n, but worst case, which is what O of x tries to do, it gives us O of n square, and we can't afford that. So what are we going to do now? Well, our intuition is very correct, just finding out the element like 99, 98, 97 within the list or within the set. That's a good approach. The only problem is that we don't necessarily have to do it for every element, right? We can just do it for one type of element. So what we can try to do is, let's say we are at 100. We can find 99, or we can go along the route of 101. That means I can either check for n minus 1 or I can check for n plus 1. What that approach will lead me to is, instead of, going over every element and doing this, what I can check is, hey, does 99 exist in this set? No, it doesn't. So I'll just start checking for 101. Does 101 here exist? Nope. So in that case, my max length is, or max count of the sequence is going to be 1. What about 4? So what I'll do here is check if 3 is present in the set. 3 is present in the set, so I won't execute it. I won't go any further. I'll just move to the next element. The reason I'll move to the next element is because I want to ignore this, because this is a very big kind of a loophole that we have. Because if we go down this route, we'll have to do 3, 2, and 1. We don't want to do this. So we'll just find out the consecutive element starting from the smallest element of the sequence. And how do I find out the smallest element of the sequence? It's simple. If this is 4 and we know 3 exists, that means 4 is not the biggest element. If 3 exists and 2 also exists, that means 3 is not the biggest element. If 2 exists and 1 exists, 2 is not the biggest element. If 1 exists and 0 does not exist, that means 1 is the smallest element, and there we go. That is our smallest element. Then we can work our way upwards. We can check if 2 is present in the set, if 3 is present in the set, if 4 is present in the set. What that will allow us to do is only loop over one of the elements, and that will make our time complexity O of n. Instead of going in the rabbit hole of going over every element, so let's say we go over 3, 2, 1. Instead of doing that, we'll only do it for the smallest element, which is 1, 2, 3, 4. If you don't understand it, stay with me. So let's say we are having this set as we are having this list as an input. This is the set that we have converted it to. We still need the set because we need to access the elements in O of one time. Not just access, look up the elements in O of one time. After that, what I check is if n-1 exists, then what we are going to do is just move to the next element. But if n-1 does not exist, then I'll search for n+1. So let's start. Is 99 present in the set? Nope. So I'll check if 101 is going to be present in this set. The reason I did 99 is just to check if this is the smallest element or not. If 99 is present in the set, 100 is not the smallest sequence or the smallest element of the sequence. For example, in 1, 2, 3, 4, the smallest element of the sequence is 1. We know that because 4 cannot be because 3 exists, 3 cannot be because 2 exists, and 2 cannot be because 1 exists. This is the exact simple logic that we are trying to apply here. We are finding out, hey, 99 present in this set? No, that means 100 could be the smallest element of the sequence. So is 101 present? No, 101 is not present either. So that's not going to be the smallest sequence, or it's not going to give us the value of this sequence. Let's go to the next one. We have 4 here. So does 3 exist in the set? It does. So that means 4 is not the smallest element of the sequence. I don't want to waste my time on this. I'll move to the next one. I'll get to the sequence of 4 when I get to the smallest element that's present in the sequence of 4. Okay. So I'm on 200. Is 199 present? No. So I'll just check if 201 is present, because 200 could be the smallest element of the sequence. And no, 201 is not present either. What about 1? Is 0 present in the sequence? Nope. So 1 could be the smallest element. Is 2 present? 2 is present. So let's increase the length. So we have 1 and 2 as the length. And then we'll again go. 2 plus 1 is 3 present. 3 is present. So we'll add 3. 3 plus 1 is 4 present. 4 is also present. Is 4 plus 1 5 present? 5 is not present. So our max length as of now is 4. Because before 1, all the max length was 1. But now we have 4. After that, we check for 3. In 3, first we check again, n-1 is present. 2 is present in the set. That means it's not the smallest element. For 2, we do 2 minus 1, 1. Is 1 present in the set? 1 is present in the set. That can be our smallest element of the sequence. The reason we take this n-1 and then do the n+1 approach is because this makes our time complexity O of n. Instead of going down the rabbit hole for each and every element, we smartly figure out which element is the smallest and only go down the rabbit hole for one element. So that's the entire solution. Let's go ahead and code it up. So the very first thing, as I said, I want to convert this nums into a set. So I have a set of nums. After that, what do I want to do? I want to go over each element of this nums list, and then I'll check, hey, does n-1 exist? If n-1 exists, I don't want to do anything, I'll just skip. But if n-1 does not exist, in that case, I'll do the looping of going over n+1. So now let's go over it step by step. We have for num in nums. And now I have access to 100. The first thing I want to check is if num-1 is present in the nums set. If num-1 is present in the num set, what do we want to do? In that case, we want to ignore. So you can do continue, or you can just reverse this condition. If num-1 not in num set, in that case, what I want to do is just have a max count, right? But before that, I have to go over and loop everything. So what I want to do is find out what is the max length I can find here. So I'll just create a variable which is length is equal to 1. There's one element as of now with us. And now I'll do the following. I'll have while num plus the length is less than, and not less than, but first let me just put this in bracket. So while num plus length, what I've done is initially num plus 1. If num plus 1 is present in the nums set, that means length will be plus equals 1. What the hell is going on over here? Here, what we are trying to do is, let's say we are on 1. We have found out that this is the smallest element. Cool. So if num-1 is not in the num set, we are doing this while num plus length minus num set. So what we're doing is 1 plus 1, because initially length is equal to 1, right? So we have 1 plus 1, 2. Is 2 present in the num set? 2 is present. So I just increase the length by 1. So length, which was initially 1, is now 2. Then I do nums plus 2, which is 1 plus 2, which is 3. Is nums, is 3 present in the set? Yes, it is. So I'll do length plus equals 1. So this is 3 now. And then I'll do 1 plus 3. 4. Is 4 present? Yes, it is. So length is now 4. And now finally we have 1 plus 4, 5. 5 is not present. We get out of the loop. And that's why this particular thing is done. This is what it's simulating, you know. After that, we'll find out the max length till now. And to find out the max length, I first have to store a max length variable outside of the for loop. And then I can just do max length is equal to max of max length and length. In your interview, you can ask your interviewer, can you use max function or not? If you can't, you can just use if max length is greater than length, then that means everything is good. But if max length is smaller than length, then you need to update the max length. But either way, I think this should be fine. You know, if you're solving such a difficult problem and you don't know how to find out the max element between the two elements, you're kind of fucked. So after we found out the max length, what we want to do is just return the max length. And that is our entire solution. So for every single one of them, you know, we have maximum length with us. So let's say for one, we found out that the length here is 4. So we store that in a max length variable and we'll update it in the future. Let's say we have 101, 102, or actually let's just put 99 because we went over this. So there's 99, 98, 97, 96. So we go over 96 and then start checking. 97 is present, 98 is present, 99 is present, 100 is present. So what is the max length now? And if the max length exceeds this length, we can update. So yeah, either ways, this is what we have. Let's try to run it and see if it works out. Yeah, it does work out, and let's submit. And I run into a time limit exceeded problem. The reason I run into it is a very silly mistake. So after we've completed the while loop, that's not when we want to figure out max length, because we only don't want to figure it out in the if condition. We also want to figure it out outside of the if condition. So the length can be equal to 1 over here, so that, length is accessible outside of the if condition. Because here's the thing, length is equal to 1 will be the case even if, let's say we have no elements. So in 100, what is the max sequence? The max sequence is 1, it's not 0, right? So length equals 1. Even though 99 does not exist in the num set, length is going to equal to 1. That's why we have to shift it outside. And then we have max length is equal to max of length. Cool, that's fine. And now we can try running this again with the same test case. So let's use this test case and now run it. And I believe we still run into time limit exceeded error. And the reason we run into this time limit exceeded error is because if you closely observe the test case, so if you open the test case and truly observe it, I don't know how much time you have, what they've done is towards the end they've just put in a bunch of zeros. If you have a bunch of zeros, you're just iterating over this and it will take a ton of time. And this is very smart, because if you want to run it in O of n time, it should be the length of the numbers. They did not say that n should be the length of unique numbers, but either ways we can optimize this, and the optimization is that we loop over the set. We don't loop over the list, we loop over the set, because the set will remove all the duplicate elements, and that's what we want. Now if I run it, it will work out, and if I submit, that will work out as well. So that's one thing to keep in mind. This is kind of an optimization. Even without this, your solution is O of n. They did not mention that n should be the length of unique numbers or non-duplicated numbers. But either case, this is a great optimization to keep in mind. So again, the time complexity here is O of n. The space complexity is O of 1, or you can say O of n, because we have created a set, right? In the worst case scenario, the set is exactly the same as the list. So that's O of n.